Section 1.2 is about Gedanken or thought experiments. We have learned how it's possible to make a real device that can split a beam of silver atoms according to the z component of spin of the 47th electron in each atom. And now we're going to pretend that we can make multiple Stern-Gerlach devices, orient them in different ways, send the output of one Stern-Gerlach device beam into another Stern-Gerlach device, and try various combinations. The first experiment goes like this. We begin with an SGZ device, just like the kind we've been discussing. Beam of atoms comes in, and it splits the beam into the spin up and spin down parts. We're going to ignore the spin down part and take the spin up part of the beam and send it into another device. So this is the part of the beam that has a z component of spin equal to plus h bar over 2. And let's say that there is a number of atoms n0 coming through this part of the experiment. We send those guys in to an SGZ device, another SGZ device. And this is what happens. This is what would happen. Nothing would come out with SZ equals minus h bar over 2. All of the atoms that went in would come out with SZ equals plus h bar over 2. And 0 of them would come out. That's not weird if you've determined that the z component of spin of an atom is plus h bar over 2 after the first measurement, and you measure again. It's reasonable that you would get the same result on the second measurement. Now let me introduce a little notation. The electrons that have SZ equals plus h bar over 2, or in other words, spin up, are referred to as being in the state plus z. And we draw a little symbol for the state as a vertical line, and then the name of the state, and then an angle bracket. This is a ket, as a matter of fact. And the electrons with Sg equals minus h bar over 2 are said to be in the state minus z. Let me go on to experiment number 2. Again, a beam comes in to an SGZ device. Again, we will ignore the spin down output and take the spin up output. SZ equals plus h bar over 2. Let's say there are n0 atoms coming through that part of the experiment. Now I'm going to run them into the input of an SGX device. It's the same as an SGZ device, only rotated 90 degrees, so that the inhomogeneous magnetic field points in the x direction, and the device measures the x component of the spin of the atoms that come into it. What would happen is half of the beam would be found with x component of spin equals plus h bar over 2, and half would be found with x component of spin equals minus h bar over 2. N0 over 2 and 0 over 2 are the numbers. The states are referred to as plus x and minus x. Oh, and a comment about the numbers of atoms. It's all a matter of probabilities. We can't predict the exact number. It wouldn't be exactly half of the incoming number of atoms. If you send one atom through the apparatus, there's a 50-50 probability that it would come through the plus x or the minus x output at the end. When we say that it would be 50% of the incoming, we are imagining that the number of incoming particles, n0, is very large and the statistical fluctuations would be negligible. If instead of using the Sz equals plus h bar over 2 output as input to the SGX device, we use the Sz equals minus h bar over 2 output, we would get the same result, 50-50 split of the atoms coming out of the SGX device.